like to now look at another application of side-side angle triangles. In this example, it says that a Coast Guard station, Zulu, is located 120 miles due west of station X-ray. A ship sends out an SOS that is received by both stations. From Zulu, the bearing of the ship is north 40 degrees west. From X-ray, the bearing is north 30 degrees west. Two questions. Number one, how far is the ship from each station? And then number two, if a helicopter flies to the ship at a rate of 200 miles per hour from the closest station, how long until it reaches the ship? Okay, so let's work on, first of all, the first question of how far is the ship from each station. Okay, to do this, we first want to go and we want to draw a picture of what we're looking at. Okay, so for part one, let's see if we can draw a picture. Okay, the first thing in this problem said that the station Zulu and the station X-ray are 120 miles apart. Furthermore, it said that Zulu is located due west of the station X-ray. So let's say that the station X-ray is right here. Then that means due west would be immediately to the left. And so we'll label that station Zulu. And we know that it's 120 miles between those two stations. Okay. The ship, we're going to say that the bearing from the ship, we're always taking the bearing basically from the station, so we can kind of figure out the ship, where the ship is based on the bearings. The first problem said, or the next part of the problem said, from Zulu, the bearing of the ship is north 40 degrees east. And so what I'm going to do is I'm going to draw kind of a dotted north line from station Zulu, and then it said that the ship was north 40 degrees west. And so from the north line, we're going to want to rotate 40 degrees towards the west. And so this line would represent the line on which the ship is located. Okay, now, from the other station, I'm going to do the same thing. I'll draw a north line from that station. Okay, and this particular problem said, or this particular piece of the question said that the ship was located at a bearing of north 30 degrees to the west. Okay, so on this one, there's the north line. We want to rotate 30 degrees to the west. And so there's going to be a rotation in here of 30 degrees to the west. And then wherever these two lines meet up is going to be where the ship is located. Okay. Let me scroll up. I'm going to just double check some information up here. Okay. Actually, I believe I have something wrong in my problem, and I need to correct that. I miscopied something. Do you see, actually it says from Zulu, the bearing of the ship is north 40 degrees west. I need to correct that. That bearing should actually be north 40 degrees east. Okay, and I have my picture drawn correctly. I just had copied the problem down incorrectly to begin with. Now, from here, okay, I can use the law of sines to determine some of these distances. Okay, what I'm going to do is I'm going to actually let this distance in here from Zulu to the ship, I'm going to label that distance D sub Z to represent the distance from Zulu to the ship, and then I'm going to label this distance over here D sub X for the distance between X-ray and the ship. Okay, whatever labeling you want to use there is fine, but let me use that for the moment. Okay, we need to find both of those distances. Let me first do D sub Z. Okay, on this one, we need to figure out some other angles. Okay, first of all, we can figure out the angles inside here by subtracting 90 degrees and the angle that I have given. Okay, I have 40 degrees on the outside there. I know 90 minus 40 would end up giving me 50. I can figure out that angle. Similarly, over here on this side, I have a 30 degrees given. Okay, 90 minus 30, that would be a 60-degree angle. And then I can figure out the angle in here by adding up and saying, okay, 180 degrees minus the 50 degrees minus the 60 degrees, that would end up being 70 degrees up top. Okay, to set this up, I can use the 70 degrees with the 120 that's opposite of that. That's the distance. So I can use sine of 70 degrees and the opposite side, which is 120. And let's say I'm trying to figure out the distance between Zulu and the ship. So that would be dz. The angle that goes with that side is 60 degrees. So I'll have sine of 60 degrees and then divided by d sub z. Okay, to solve this, I want to multiply both sides by d sub z. Okay, that will cancel out the z's on d sub z's on that side, and then I want to multiply by the reciprocal of what's behind dz, and so I'll end up getting dz equals sine of 60 degrees multiplied by the reciprocal of what's behind d, which is 120 over sine of 70 degrees. Okay, doing that, I'm going to get that dz is equal to 110.592598.2, and this will be in miles. Okay, so there's the first part of what I'm wanting to find. This is the distance from the station Zulu. Okay, on the second part, to find the distance from the station X-ray, I can do something similar. I can put sine of 70 degrees, once again, over 120. The difference is I'm wanting to solve for a different side, so y'all can see that the 50 degrees goes with the side dx. And so we'll do sine of 50 degrees over d sub x. Okay, once again, multiply both sides by d sub x. That will cancel this side. And then to solve for d sub x, multiply both sides by the reciprocal of what's there behind d sub x. So I'll have sine 50 degrees multiplied by 120 over sine of 70 degrees. Okay, so d sub x, type that in your calculator, make sure you're in degree mode, and we have 97.8248969 miles. And that was the distance to station X-ray. Okay, so that's answered the first part of my question, and that was how far is the ship from each station. Okay, the second part of the question said that if you were able to send a helicopter from the closest station, okay, we know that the closest station is X-ray now. All right, and that helicopter is flying at a constant rate of 200 miles per hour. How long would it take it to reach the ship? Well, what we can do here is we can go back to algebra, and we know the formula d is equal to r times t. In other words, the distance is equal to the rate times the time. And this particular part of the problem is wanting to know how long. So we can solve this equation for t by dividing both sides by r. So we have that t is equal to d over r. So to figure out how long, we can say we want the distance on the top, the rate on the bottom. The distance to station X-ray was what we found earlier. That was 97.8248969 miles. And then the rate here, it said the helicopter was flying at a rate of 200 miles per hour. And just divide those two numbers on your calculator, and we'll get 0.4891244.815. And then this would be in hours. So it's going to take just a little bit less than a half of an hour to reach that other, or that ship. Of course, if it wanted you to convert that into minutes, or if it wanted you to, convert that, we can definitely do that. But for now, we'll just leave that at 0.489, and then the decimals in hours. This concludes this lesson on solving applications involving side-side angle triangles.